All right, we're doing trim A in nutshell volume 2. Let's say the vessel is floating at a draft forward 4 meters and aft 5 meters. And the first point that we know of we talk about is center of rotation. By what is the definition of center of rotation? Anybody in the class? What is the definition of center of rotation? Anybody?
Sir, center of flotation can be imagined as an imaginary point for which whole mass of the body is supposed to be concentrated as to be seen flown.
Negative. That's not the right definition. Anybody else? How do you define center of rotation? With Captain Rajat Jain, where have you reached in stability?
Sir, we have just started hill ship. The list is completed. We have just started a hill ship.
Okay, all right.
Sir, the geometric center of the water plane on which the vessel.
The geometric center of water plane area is known as the center of rotation. The GC of the water plane area. That's the correct definition of center of rotation. Then the next one. What is LCF? How do you define LCF? Longitudinal center of rotation.
Sir, center of flotation से distance को aft.
Aft. You have to be very specific now.
So the distance between after perpendicular and the center of flotation is known as LCF.
Correct. Distance from aft perpendicular to center of rotation is known as LCF. Absolutely correct. How do you define center of buoyancy?
It lies on the geometrical center of the ship, sir.
Again, not a correct definition. I want a precise definition. I want a precise definition. Come on.
Sir, the center of mass of the displaced water.
Negative. It is again a geometric center. But of what? That is a question.
Underwater volume of ship, sir.
Correct. This is the GC of the underwater. It is the geometric center of underwater volume. That is the center of buoyancy. And therefore, consequently, LCB is the distance of the aft perpendicular to the center of buoyancy. And therefore, KB is the distance from the keel.
सर LCB तो फॉरवर्ड परपेंडिकुलर नहीं सर, ये LCB वाला समझा दीजिए एक बार.
LCB is the longitudinal center of buoyancy, is the distance between the aft perpendicular and the center of buoyancy.
Okay, sir.
KB is the distance between the keel and the center of buoyancy. What is center of gravity? COG.
Concentrated.
It is the
Concentrated, sir.
It is the geometric center of the mass or the weight of the ship. That is center of gravity. And so therefore, what is LCG?
Same, sir. Distance from aft perpendicular to COG.
Correct. And what is KG?
KG is a distance from keel to center of gravity.
Correct. Okay, are these basic definitions clear to you? These are the basic definitions. Next, what is hydrostatic draft equal to? The draft at center of rotation is known as hydrostatic draft. Draft at center of rotation is known as hydrostatic draft.
सर सेंटर ऑफ फ्लोटेशन मतलब सर वहां तक डूबा हुआ है, सेंटर ऑफ फ्लोटेशन तक.
जी, वहां तक डूबा हुआ है.
एग्जैक्ट सेंटर ऑफ फ्लोटेशन तक, उसको बोलेंगे सर हाइड्रोस्टेटिक ड्राफ्ट.
The draft at the center of rotation is known as hydrostatic draft.
ओके सर.
You calculate hydrostatic draft. Hydrostatic draft is equal to draft aft minus or plus minus if it is a stern trim plus if it is a head trim is equal to draft aft minus if it is a stern trim plus if it is a head trim into LCF upon LBP. This is the formula for hydrostatic draft. So in this particular scenario, if your forward draft is 4 and aft is 5, It will be 5 minus, because it's a stern trim. How much is the trim?
1
1
meter.
meter. Into LCF. This will be given to you in the question. LBP given to you in the question. And this will give you your
Hydrostatic drop.
Any doubt up till now? Any doubt up till now?
All clear, sir.
Okay.
Sir, while calculating hydrostatic draft,
Yes,
why
please.
are we always taking draft aft? Why not draft forward, sir?
Can take draft forward also, no problem. But this is more convenient. That's why. Because if my forward draft is 4 and aft is 5, is the draft over here will definitely be less than 5. So इसलिए minus. Because I've got a stern trim. If my vessel was down by head, then it would have been 5 plus. Because my draft over here would have been more than 5.
Okay, sir.
That's why.
And sir, here no factor of density. No.
Nothing. No factor of density. No factor of density.
ਵਾਹਿਗੁਰੂ 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 ਜੀ ਵਾਹਿਗੁਰੂ 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 ਜੀ ਵਾਹਿਗੁਰੂ
Hanji. So hydrostatic draft is calculated in this manner. Now, hydrostatic draft taken in the morning and hydrostatic draft taken in the evening. Difference of the two hydrostatic drafts will give me what?
Mean hydrostatic draft, sir.
The mean difference of the hydrostatic draft taken in the morning and the hydrostatic draft taken in the evening will give me what is called as the mean rise or mean sinkage of the ship. That means how much is the bodily the ship has gone down or come up. If I'm loading, then I've gone down. If I'm discharging, then I've gone up. Is this okay with everyone?
Yes, sir.
All right.
Sir, this mean hydrostatic draft will depend upon different densities also, no?
No, there is nothing. No, I have not written any word called mean hydrostatic draft. I have not written anything like that. There is nothing known as mean hydrostatic draft. So you'll have to be very precise in your statements that you make. It is a difference of the two hydrostatic drafts which give you a mean rise or a mean sinkage. That's all. A mean difference, a difference of the two hydrostatic drafts is what I get. A change of draft at the center of rotation.
Okay, sir.
This mean sinkage or rise is also equal to W upon TPC. This mean sinkage or rise is equal to W small upon TPC. Small w is a weight which is being loaded, let's say, anywhere on the ship. So this is a weight which is being loaded. It could be anywhere. It could be here, it could be here, it could be kahin pe bhi, aage, piche, daएं, बाएं. TPC is the tons per centimeter immersion. So let's check the units of it. W is in tons. TPC is tons per centimeter immersion. Centimeter goes on top. So this unit on the left hand side will be in centimeters. Is formula number 12 okay with everyone?
Yes, sir.
All right. Now, so this is all about the bodily sinkage. Now let us come to the trim. That means there is a certain change in trim which is going to happen. So initial trim, difference of the final trim. Will give me TC, change in trim or trim caused. initial trim, that means the trim in the morning. Difference, final trim in the evening, gives me TC. Change in trim, also called as trim caused. Also called as trim caused. So, in the morning, my trim is 1 meter stern. In the evening, my trim is 2 meters stern. How much is the TC?
1 meter.
1 meter, which side?
Astern, sir.
Does everybody agree on this? Morning, 1 meter by stern. Evening, 2 meters by stern. TC, 1 meter by stern.
Yes, sir.
Okay, morning, 1 meter by stern. Evening, even keel. How much is the TC?
Sir, 1 meter by head.
Correct. The TC is 1 meter by head. Bow is going down. Morning, trim, 1 meter by head. Evening trim, 1 meter by stern. How much is the TC?
Sir, 2 meter by stern.
2 meter by stern.
ये समझ में नहीं आया सर.
मॉर्निंग में ट्रिम 1 मीटर बाय स्टर्न थी.
इनिशियल
शाम
1
को
मीटर
ट्रिम
हो गई, फाइनल 1 मीटर हो गई.
इनिशियल 1 मीटर बाय इनिशियल 1 मीटर बाय हेड थी.
हाँ सर.
फाइनल 1 मीटर बाय स्टर्न है.
यस सर.
तो टीसी कितना है?
2 meter by stern, sir.
हाँ जी.
Sir, 2 meter by stern.
Correct. Is that okay with everyone?
नो सर.
अरे भाई, कितना चेंज ऑफ ट्रिम हो रहा है? 1 मीटर हेड से 1 मीटर, पहले इवन कील गया, फिर 1 मीटर स्टर्न गया.
2 मीटर सर.
तो टोटल डिफरेंस कितना हुआ?
2 मीटर सर. समझ गया सर.
और बाव किधर जा रहा है? बाव ऊपर जा रहा है.
यस
दैट
सर.
मींस 2 meters by stern.
स्टर्न सर.
Morning, the trim is 1 meter by head. Evening, the trim is 2 meters by head.
Sir, 1 meter by head.
By
CC.
head.
Correct. Is that okay with everyone?
Yes, sir.
यस सर.
Morning, trim is 3 meters by stern. Evening, trim is 1 meter by stern.
Sir, 2 meters by head.
2 meter by head.
Correct. ठीक है? Is that okay with everyone?
Yes, sir.
सर लास्ट केस में समझ में नहीं आया सर.
Last case में समझ नहीं आया. Morning, 3 meters by stern. Evening, 1 meter by stern.
Okay, that is 2 meters sir.
2 meters
By
by
मीटर
what?
बाय
Head sir.
2 meters by head.
Okay.
The bow is going down. That's why. Because the bow is going down. Basically, bow को देखना है. Bow नीचे जा रहा है तो head. Bow ऊपर जा रहा है तो stern. Simple.
ओके सर. क्योंकि जो आपने फर्स्ट सिनेरियो बताया था ना, जिसमें 1 मीटर और 2 मीटर स्टर्न किया था आपने, लेकिन उसमें क्या था कि 1 मीटर से 2 मीटर हुआ था, यहाँ पे 3 मीटर से 2 मीटर हुआ है
3 मीटर से
लास्ट
1
केस
मीटर हुआ,
में। हाँ
3
लास्ट
मीटर
केस
से 1,
1 मीटर हुआ है, इसलिए वो हेड बाय हेड आए।
करेक्ट.
ओके सर, थैंक यू।
So now TC, trim cost, is equal to trimming moment upon MCTC. TC, trim cost, is equal to trimming moment upon MCTC. MCTC stands for moment to change trim by 1 centimeter. Trimming moment is W into D upon MCTC. Trimming moment is W into D. So now this W, which is acting down, the lever through which this is going to act will be this much. This is your D.
Excuse me, sir. Can you please repeat, sir? Your voice was break, sir.
This W, which is acting downward, is acting through a lever of D. The D is the lever. E is the center of gravity of the cargo in the hold. G is the center of gravity. So it is the distance between GF. D is the distance between GF. G is the COG of the cargo in the hold. And F is the center of flotation of the ship. I repeat, G is the center of gravity of the cargo in the hold. जिस होल्ड में उस कार्गो को लोड किया गया, उस कार्गो का सेंटर ऑफ ग्रेविटी इज द जी. F is the center of. So GF will be the lever through which this W is going to be acting. So this W is going to be acting like this and will cause the vessel to dip down like this. The dipping down is called as a trimming moment. So the force is W into the lever GF. That is the trimming moment. And that divided by the MCTC, moment to change trim by 1 centimeter, will give me what is called as a trim cost or change in trim or total change in trim.
Sir, your voice is not coming clear, sir.
Is my voice not clear to everyone?
Yes, sir. It is coming broke sometimes.
सर ब्रेक सर बीच में टूट रही है सर आवाज.
अभी
Okay, I'll
जो
repeat
आपने
once again.
ये जो आपने समझाया ना टीसी के बाद में, उसके बाद में कुछ सुना ही नहीं आया सर अच्छे से.
W is the weight which is acting downward like this. ये समझ में आ गया?
हाँ सर.
ये जो W है, this is acting through a lever of GF. ये समझ में आ गया?
Yes sir.
So the trimming moment is W into GF.
Okay, sir.
The trimming moment W into GF divided by MCTC will give me TC.
Okay, sir.
TC is the trim caused or the change in trim, जो अभी हम निकाल रहे थे पीछे 13 नंबर में.
Okay, sir. So GF is D. This D is GF.
GF is D.
Okay, sir.
GF is D. Is this okay with everyone, the formula?
अगर सर ये वेट फॉरवर्ड की जगह पीछे होता तो भी सेम ही सिनेरियो रहता ना सर?
सब कुछ सेम रहेगा, कहीं पे भी ये वेट को डाल दो.
बट सर अगर इन केस जैसे मिडिल वहां पे रख दिया तो फिर ये जो जीएफ है वो अपने को दिया हुआ होगा सर, ये वो कैलकुलेट करना पड़ेगा. आई मीन सर अगर ऐसे अभी तो ये परपेंडिकुलर है.
I can't hear you. मेरे को नहीं सुनाई दे रहा.
सर जैसे कैसे बताऊं? ठीक है सर, ठीक है.
Let this weight be anywhere. कहीं पीछे भी अगर होगा, the formula will remain the same.
Sir, there is one question, sir.
If the weight is put on top of the center of rotation, then GF will be 0.
Okay, sir.
Sir,
Then TC will be 0. There will only be a mean rise or a mean sinkage.
जैसे सर ये वेट एलसीएफ के पास होता, अभी मान लो जैसे एलसीएफ जैसे आसन में ना एलसीएफ के साइड में एक हो गया सर.
हाँ जी.
सर मैं बोल रहा हूँ जैसे एलसीएफ के पास में रख देते सर वेट को, जहाँ पे आपने एलसीएफ लिखा हुआ है.
अगर मैं वेट को यहाँ पे लोड करता हूँ,
नहीं वो तो ऊपर है ना सर, नीचे बोल रहा हूँ सर.
ऊपर और नीचे क्या फर्क पड़ता है? ये तो खाली लॉन्जिट्यूडनल डिस्टेंस की बातें हो रही हैं. How does it matter whether it is on top or bottom? It doesn't matter. कहीं पे भी रख दूंगा मैं. It is the longitudinal trim that we are talking about, ना longitudinal stability की बातें हो रही हैं. तो height तो doesn't matter.
Got it, sir.
I have one question, sir.
Yeah, please go ahead.
Sir, if the vessel will go down by head, will there be any change in the formula, sir?
If the vessel is down by head, the formula remains the same. dA plus head. The sign will become plus.
बट सर आपने अभी बताया था सर कि जब सिंकेज हो रहा है तो बाय स्टर्न होता है सर, फिर राइज हो रहा है तो फिर वो बाय हेड होता है. लेकिन अगर वेसल डाउन बाय हेड चला गया सर, तो उस केस में मतलब आफ्ट ड्राफ्ट जो है फॉरवर्ड ड्राफ्ट से कम है सर, तो उस केस में क्या होगा सर? मेरा क्वेश्चन.
तो हाइड्रोस्टैटिक ड्राफ्ट निकालने के लिए यहाँ पे साइन प्लस होगा. इस फॉर्मूले में कोई चेंज नहीं आएगा.
ओके सर, ओके, थैंक यू सर.
ये फॉर्मूले में कोई चेंज नहीं है, चाहे जहाज डाउन बाय हेड हो चाहे डाउन बाय स्टर्न हो, डजंट मैटर. This will remain the same. W, let's check the units. W is in tons. GF is in meter.
Meter.
Moment to change trim by 1 centimeter. Moment is TM. To change trim by centimeter. TM cancels. Centimeter goes on top. So unit of TC
centimeter
will be centimeter. ये समझ में आ गया?
Yes, sir.
This is TC. TA, change in trim aft, is equal to TC, change in trim total, divided by LCF, multiplied by LCF, divided by LBP. This will give me change in trim aft. Change in trim aft, TA. This is change in trim aft. Change in trim aft plus change in trim forward will give me TC, total change in trim. Therefore, change in trim forward is equal to total change in trim minus TA. Is this okay with everyone? Hanji, any doubts so far? Whatever we have done.
Clear, sir.
Hanji. Any doubt?
Clear,
Right.
sir.
Okay. What I want you to do is, let's stop here. I want you to go through the chapter in nutshell series, the chapter on longitudinal stability. Please read that. Okay, that's what I've done today from. And after that, the initial bit of trim A. Just, I want you to do example 1. Trim A. Is that okay? So please read
Yes, sir.
longitudinal stability and do example 1. Solved example hai. I want you to do that of trim A. Then I'll be doing that in the next class. I'll be explaining all this. Okay? All right?
Yes.
Okay. So see you then. Bye.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.